Okay, think about this for a second. Your car tires. You rely on them every single day, right? They're these incredibly complex bits of engineering keeping you safe on the road. But have you ever, actually wondered where they came from? Because there's this story, this really persistent idea that the modern car tire, the super durable ones with all the fancy treads, that they were actually invented by NASA, up in space,
Hmm.
and then brought down here for us. And honestly, it's a really compelling story, isn't it? I mean, the thought that your tires might have some kind of moon roving DNA, that's pretty cool. It sort of makes sense, too. You figure space pushes technology to the limit. So today on this deep dive, that's exactly what we're going to do. We're going to journey into that whole narrative, kind of peel back the layers and figure out what the real story is. And I got to tell you, the truth behind it. It's actually even more interesting, more insightful than the myth.
It really is. That idea of space tech just appearing on Earth, it crafts people.
Experiment.
And, there's a grain of truth there that feeds it. There absolutely was this groundbreaking collaboration. NASA working hand in hand with companies, Goodyear, for example, during the Apollo missions, that partnership definitely led to some incredible breakthroughs. But the key thing to understand, and this is where it gets fascinating, is that it wasn't like they suddenly invented the modern tire fully formed, on the moon. It was more of a profound evolution, an acceleration, really, of engineering thinking that absolutely transformed tire tech back here on Earth. And understanding that difference, it tells you a lot about how big innovations actually happen, less eureka, and more pushing boundaries in really extreme situations.
Okay, right. So let's just dive straight into that. Let's tackle that common belief head on for you listening. Do the tires on your car actually come from the moon? Because the story lots of us have heard is that, yeah, the high durability, the complex treads, maybe even run flat tech, all dreamed up by NASA for the moon missions and then just, boom, handed over for our cars. Sounds almost like a movie plot.
And you could see how that story took root. That collaboration between NASA and companies like Goodyear, it was real, it was intense, and it was very public during Apollo. People saw these amazing lunar rovers, the moon buggies doing incredible things up there.
Yeah.
So it's kind of natural to connect the dots, right? You see this amazing space tech, then you see tires getting better back home.
Yeah.
But while Apollo absolutely spurred huge leaps in material science and design and engineering methods, the idea that the tire itself was invented in space, that's just not accurate. It was, like I said, an evolution, really powerful, fast-track development forced by the just unique challenges of space, not a totally new invention starting from zero.
Okay, so if not invented there, what's the real link? What actually happened? To get that, we need to go back to this massive engineering problem NASA faced. They needed a vehicle, right, that could actually drive around on the moon. We're talking about the Lunar Roving Vehicle, the LRV, the moon buggy. And just try to picture that environment. It's a vacuum, no air, no roads, obviously, and crucially, absolutely zero chance of calling roadside assistance for a flat. I mean, these are missions where failure wasn't just an inconvenience. It could be, well, fatal.
Exactly.
Okay.
So the engineers had this fundamental question: how on Earth, or rather off Earth, do you design something for that? An environment so hostile, so alien. The LRV tires needed to handle conditions that are just, well, mind-bending. Think about it. Gravity, that's only 1/6 of Earth's. Driving over sharp, jagged rocks and through this deep, powdery moon dust, they call it regolith. It's incredibly abrasive stuff. And then the temperatures. Swings from, what, minus 280 degrees Fahrenheit in the lunar night?
Yeah.
Up to plus 260 degrees Fahrenheit in the day. Just insane. Your normal rubber tire, forget it. It would either freeze solid and shatter or melt into goo.
Right, it just wouldn't work. So that's where Goodyear came in with this really clever solution. And this is where it gets wild, because what they developed for the LRV, it looked nothing like a car tire. Nothing at all. It was this unique, airless mesh design made out of, get this, zinc-coated piano wire. Seriously, like from a piano.
Yeah.
This wire mesh gave it flexibility, incredible strength, and amazing durability, all without needing any air inside. So yeah, they weren't inventing the kind of radial tire we use today, the ones with belts under the tread. This was something else entirely. A totally specialized adaptation for a completely alien world.
Yeah.
Almost like a different species of wheel,
That's a great way to put it. And what's key is how they had to completely rethink design principles. They couldn't just tweak existing ideas. They had to innovate because the requirements were so extreme. First, it had to be incredibly lightweight. Every single ounce counts when you're launching something into space. Launch costs are astronomical, literally. Then, it needed absolutely uncompromising traction, not on smooth pavement, but on loose dust, uneven ground, sharp rocks. And finally, sheer durability. It had to resist punctures, tears, degradation. Failure just wasn't an option up there. So even though this mesh tire doesn't look like your road tire, The process of creating it, of solving those impossible problems, that laid this crucial groundwork for new ways of thinking about materials, about structure, about how a wheel interacts with the surface without relying on air pressure. That shift in perspective was enormous.
It's still kind of hard to wrap your head around, though. Zinc-coated piano wire. It sounds more like, I don't know, something cobbled together in a sci-fi movie than a serious piece of engineering for NASA. How do they even land on that specific material?
Well, that really speaks to the whole mindset of the Apollo program, doesn't it? They were literally designing for the unknown. The engineers basically started from scratch. What are the absolute must-have properties for something to move on the moon? It needed to be flexible to mold to the ground for grip. It needed to be strong, incredibly strong, against punctures from those sharp lunar rocks. And it had to survive those temperature swings. Rubber was immediately out, so they looked elsewhere. What materials have incredible tensile strength, are resilient but still flexible? Piano wire surprisingly fit the bill. It's designed to withstand huge tension, and it can be woven into a mesh that has both strength and give. It wasn't about making a better rubber tire. It was about inventing a whole new kind of wheel system that could actually function in that impossible environment.
Okay, that makes more sense. The genius was in ditching the old assumptions entirely. But let's bring this back down to earth for you listening. So, what does all this actually mean for your car driving around today? You're definitely not rolling on piano wire. How does this super specialized, airless, wire mesh moon wheel have any real connection to the tires you rely on every day?
That's the crucial link. That's the trickle-down effect. While you absolutely won't find those specific wire tires on your car, the engineering breakthroughs, the problem-solving techniques, and maybe most importantly, the mindset shift that came out of that intense space work, that had a direct, very real impact back here. The moon basically acted as the ultimate, most extreme test lab imaginable. It forced innovations and conceptual jumps that then filtered down into the tires we use every day, making them better, faster than they might have otherwise developed.
Right. So let's break that down. First up, advanced tread design. You mentioned the lunar surface was this mix of dust and rocks, super unpredictable.
Exactly. That wire mesh, even though it was airless, it still had to flex and grip that surface incredibly well. It forced engineers to really analyze how any flexible structure makes contact with the ground, how it distributes load, how it maximizes grip on varied terrain.
So studying how that wire mesh deformed and gripped.
That deep dive into the physics of contact directly influenced how they designed the complex rubber tread patterns we see now. They took those principles, learned from figuring out the wire mesh on lunar dust, and applied them to rubber on asphalt, gravel, rain, snow. It wasn't about copying the wire itself, but about understanding the fundamental principles of traction and stability, how to make rubber bite into the road much more effectively under all sorts of conditions.
Okay, that makes sense. And second, you mentioned high durability materials.
Yeah, this is a big one. The hunt for materials that could survive space, the vacuum, the radiation, those insane temperature swings led to major advances in polymer science, in composites, in reinforcing materials.
Things that wouldn't break down or fail under extreme stress.
Precisely. And that research directly benefited tire manufacturing back on Earth. Advanced polymers, stronger synthetic rubbers, better reinforcing cords. Much of that comes from knowledge gained or accelerated by the space program's demands. That's a key reason why your tires today last so much longer, resist punctures better, and handle temperature changes far more effectively than tires from, say, 50 years ago. The lessons in resilience learned in space translated directly to more robust tires for your car.
And then the third one, run-flat tire technology. This feels like a really direct conceptual link.
It absolutely is. Think about the core problem on the moon. You cannot have a flat tire stop the mission. You need self-reliance. That absolute need for a wheel that keeps working even if compromised, without air, without needing immediate repair. That mindset directly paved the way for developing run-flat tires for cars. Obviously, today's run-flats use reinforced rubber sidewalls, not wire mesh, but the fundamental concept is the same. Keep going safely after a puncture.
Right, you get a puncture, but you can still drive maybe 50 miles or so to get help instead of being stranded on the side of the road.
Exactly. It's a huge safety improvement. And that ability to drive away from a flat, that has a clear conceptual lineage right back to ensuring the astronauts could keep roving on the moon, no matter what.
So, putting it all together, it's clear the moon missions were this incredible catalyst, right? They didn't hand us the modern tire on a plate, but they threw down these impossible challenges.
Challenges that forced engineers to think way outside the box, to push materials and designs to their absolute limits.
And solving those problems that they'd never encountered just designing for Earth roads, generated all this new knowledge, these new principles.
Which then came back down to Earth and dramatically accelerated the evolution of the tires we all depend on. It really was about reimagining what was possible under extreme duress.
So as we wrap up this deep dive, the main takeaway is pretty clear, isn't it? Tires weren't invented in space. That part's the myth. But human ingenuity, our drive to explore and overcome obstacles, that absolutely reached space. We tackled these unbelievable challenges, pushed engineering to its edge, and the insights we gained from that. They genuinely made our lives back here on Earth safer, easier, more reliable. It's not just a tech story. It's really a testament to human creativity and, those unexpected benefits that come from aiming high.
It really is. And it makes you wonder, doesn't it? What other big challenges, maybe things happening right now in fields that seem totally unrelated, medicine, computing, materials, science, what hidden connections are being forged? How might breakthroughs in one area be quietly shaping the everyday technologies around us, the things we take for granted in ways we won't even realize for years to come? It's kind of exciting to think about looking for those threads.
Absolutely. It's all about spotting those unexpected connections, those aha moments. Well, thank you so much for joining us on this deep dive today. If you enjoyed figuring out the real story behind your tires, definitely hit that subscribe button for this channel. We've got plenty more fascinating topics coming your way that you won't want to miss. And hey, if you're curious for more surprising insights right now, why not browse through some of our previous deep dives? There's bound to be something else that sparks your curiosity. Until next time, keep questioning and keep exploring.